to our second webinar. In the first webinar, we talked about creating models, mostly fairly basic models using the 2D wizard and 2D textiles. And this time we're going to talk about how we actually use those models, what we do with them, how we export them to be able to do simulations and to make use of those. First of all, I'm just going to have a little reminder in case there are those of you who didn't come to the first webinar, just a few pieces of useful information about the TextGen infrastructure. So if you haven't found it already, the TextGen webpage is here at textgen.sourceforge.net. And basically there's a lot of information in there. There's the page that gets you to download information about installation and a lot of documentation in the documentation tab here. So that's a good place to find out information about TextGen. To download, the downloads of the Windows executables are on SourceForge. The link is here. If you go into the Files tab, you can access different versions and either the bundled version or the version without Python included. If you want to build in Linux, then you can download the code from GitHub. And the link for the GitHub page is here, where the TextGen source code is stored. And also on that page, you can report bugs and issues using the Issues tab. And there's also a couple of repositories with sample scripts and a scripting guide on there as well. So that's worth a look. And if you want to compile TextGen from source for both Windows and Linux, the instructions are on the link at the bottom of the page. So if you want to actually write extra code to integrate into TextGen, then you can do it that way. If you have any queries about TextGen, the best place to do that is to put them up on the TextGen forum. The link is there. If you ask to join, you will have a delay before you can actually post questions. You can just go there and look around and search for information without joining. But if you want to post a question, then you do need to answer, and you will have to wait for me to approve your request, because otherwise we just get inundated with spam on there. So there may just be a slight delay before you can actually post a question once you've requested to join, but I do send out an email to say that I've approved your membership, so that's fine. So this is just my sort of generic, this is what TextGen is type slide. And it basically gives you an overview of the TextGen project. In the first webinar, we looked at this area sort of over here, generating textiles using the user interface, touched on scripting, and looked at how we can manually create textiles using the user interface or use the wizards. But this time we're going to look at this section down in the right-hand side here, how we actually generate meshes and input files so that we can use the TextGen files, the TextGen models, to do something useful, how we can predict properties that we'll be able to use in our macroscale simulations. So it's this area that we're going to look at today, and we'll also touch on the microscale, because that is how we feed information in about our fiber and yarn properties for use in our mesoscale models. So first of all, we're going to look at preparing models for export, and some of this is quite basic and some of it goes over what we looked at in the first webinar, but it's worth highlighting because some of these things affect how the model exports and the quality of the meshes and whatever that you get. So just a reminder really that a TextGen model is made up of yarns, and these all have a set of nodes, and then a yarn path is interpolated between those nodes, and then cross sections are specified along that yarn. So in this case, it's a constant circular cross section. but the cross section might change. So it might have, say, a lenticular section in the middle, and then it would interpolate between the two sections. But just bear in mind, however you create your model, whether you use one of the wizards, whether you use a script, whether you just create them interactively on the user interface, in the end, all of the yarns will have this same format and look the same way, be generated the same way. So once you've created some nodes and cross sections, then TextGen will build the yarns. And so, having got the points, it interpolates between them and then generates a set of slave nodes at various points along that yarn. And if you look very closely at this, I think you can just about see on this one, but at in between each slave node, the yarn path is actually straight. So that resolution of how often it creates the slave nodes gives you a sort of a feel of how smooth the actual path is going to be that you end up with. And then in order to create a surface mesh, it takes the cross sections, creates points around that cross section, and then joins the corresponding points between the adjacent slave nodes. And that's how it creates the surface mesh. And that surface mesh is governed by the resolution, what it actually looks like. And the reason that I'm sort of saying about this now is because quite a few of the export functions and the meshing things use these resolutions. So if you're aware of the fact that this is how you change these meshes, then you can change what your exported function looks like, your exported mesh looks like. So the previous webinar showed how to set the resolution, so I'm not going to repeat that now, but it is there in webinar 1. But just to highlight that the set resolution function can take either 1 or 2 parameters. If you pass it 1 parameter, that will govern the number of points around the circumference of a section, and then it will automatically generate a number of slave nodes, which gives a good aspect ratio for the surface mesh elements. So here we've got 20, here we've got 40, and you can see that there are far more slave nodes. If you want to have more control over the distance between the slave nodes, you can pass 2 parameters. So if we did set resolution 40 and 20, so in this case, there are 40 slave nodes along the length of the yarn and 20 section points. And so you can see that the distance between the slave nodes is slightly bigger here than it was when we just left it to determine it itself. So that can give you more flexibility over how your actual outputs look. Before you export, you need to specify repeats. If you've specified a yarn which is just the smallest repeating length, then you need to generate repeats. And again, we covered that in the last webinar. And then that potentially gives you an infinite textile, which you can then specify a domain to say which part you're going to look at. So in this case, this is specified just a yarn along, which is specified by 3 points going here. You can see that there's a discontinuity here, and this is basically just for illustrative purposes. Normally you would make sure that the cross section at either end of your yarn is the same, so that it makes it continuous once you've repeated it. But this is just useful for illustrating how this has created a repeat which repeats every 10 along in the X direction, and then 5 and 5 in the X and Y, so then it repeats and offsets that way. And in this case, the domain has been specified so that it's a few repeats. And the thing to realise is that when you're exporting, it will TextGen will export the area that you've specified for the domain. So in this case, it will specify this area. When you're creating textiles with the wizards, normally they will create 1 unit cell and create the domain to that size. But if you want to, you can always change the size of the domain so that you export a larger area. And when you're exporting a composite, the domain gives the area that's exported as the matrix elements. Excuse me. So the other thing that you need to set up when you're creating your textiles ready to export are the material properties. And there are sort of two sets of properties. So the first are the fibre area, density, etc. And those will be used when TextGen is calculating volume fractions. So when you're creating a TextGen model, you create the cross section, and that's the cross section that's used for the yarn. But then the area of that cross section is calculated, and then the fibre information is used to give the actual area of fibre within that cross section. And so the fibre area divided by the area of the yarn will give the volume fraction for the yarn. And then mechanical properties can be assigned, and those aren't actually used within TextGen, but they're used in the export. So just take a quick look at TextGen. So I've got here this is just a 2D weave that's been created using the default settings in the 2D wizard. So if I want to set the properties, if I just click on the yarn properties without selecting any yarns, then it will give me the dialog, and I can set the properties for the densities, yarn densities, fibre area, etc. And so I can set those up. If I want to set up the properties for the individual yarns, I can either select one. If I do Shift select, that will select two, and then and carry on doing however many I want to select, and then yarn properties, and then I can set these values up, and this gives me the Young's modulus, shear modulus, etc. While I was preparing for the last webinar, I realised how irritating these dialog boxes are, because you can't actually see everything very well. So in the next release of TextGen, you will be able to actually expand these dialogues, so it'll be slightly less irritating. So you can just enter values into here, just but and the thing to realise is that you can also change the units. So if I wanted kilograms, or to change that to say grams per metre, I can do that. And then when it exports, then it will change them all to SI units so that everything is consistent. And the same goes for, I could change these values. These are actually, there is actually a value in, there are default values for these. You can see, but you could actually change those, change it to gigapascals or just pascals, whichever you want, and it will adapt and make sure that everything ties up when you export. And then if you want to set the matrix properties, this is the really irritating dialog box, which you can now expand in the new version. Same again, you can set those properties, and they'll be used in the export. So on to, oh yes, just a reminder. So once you've got your model all set up, do save your model. So just save it as a TG3 file before you try any of the exports. Mostly the textiles are reliable. The export functions are reliable, but occasionally it might crash, and you don't want to have lost all your well set up model. So make sure that you save it in the TG3 format, and then if something does go wrong, then you can reload it to carry on. Just a reminder that you can save in the standard format is what it will do by default, and that saves all the textile and the yarn data. Minimal creates just the textile data, so it's the weave data that's created by the wizards. So obviously that's only applicable if you have created your textile by one of the wizards, or if you, for some reason, you want all of the mesh data, all of the data at the slave nodes, then you can do the full export. But do remember to save your model before you start doing anything else. So looking at how we use TextGen as a preprocessor for generating the textile models, some of the things are predefined, so like creating exports for predicting mechanical properties that can be generated as export from TextGen and it's all set up ready to go. But if you want to do something else, say you want to model impact or damage, then you can export the model, and you might need to do some work to actually set up the simulation and look at the input that you need to create in order to do that. So TextGen will do some of the work for you, but not necessarily all of it, depending on what you're doing. So the first thing we're going to look at is simulations for predicting mechanical properties, which is, I think, probably the most common thing that people do. If you've looked at the tutorial online on the TextGen website, you might have seen this diagram, which basically gives the workflow that we use when we're doing an elastic analysis to create predict properties. So first of all, we input the material properties. We might do some sort of microscale simulation to predict yarn material properties, or use an analytical method. Create our TextGen model, then export to an input file. We might want to customize that. If you want to do something that's a bit different to how it's been set up automatically in TextGen, you can edit the input file and then run the simulation. And there are some files which are supplied with TextGen, which will enable you to automatically extract material properties. And that's all described in this link here. But we're going to look a little bit at that now. So getting the material properties to input into TextGen in the first place, you might do a finite element analysis. If you're looking at, if you had a textile which was something like this, which is a fairly idealized one, but the cross sections are constant, so it's a reasonable assumption that in this you would probably have a uniform volume fraction within your yarns. So in this case, you might do something like set up a simulation which says, OK, we're going to assume that we've got hexagonal packing of our fibres. We're going to assume that we've got a 76% volume fraction within the yarns. Set up the simulation, run it, and then that will give you the material properties which you can then put into TextGen. Alternatively, you might want to make use of the data which is exported from TextGen, which includes the volume fractions in the yarns. So if you have many apologies, my PowerPoint has just crashed. The wonders of modern technology. Where have we got to? Here. OK, hopefully that won't happen again. OK, so what was I saying? Yeah, so if you've got a model where the cross section is changing, then obviously the volume fraction within the yarn is going to be changing along the length of the yarn. And in that case, TextGen will export an el.eld file with the local volume fraction information for each element. And that looks something like this in the file. I've realized that this is an extract from an actual the file, the .eld file. And so it starts off with a header which tells you what the elements in the file are, and then these are some of the entries. So I've just taken a few sample entries. So I've just realized as I was putting this presentation together that the header isn't actually quite right, because it gives the first element as being the yarn index, whereas in fact the first element of each row is actually the element index. So the first one is the element index, and then the next one is the yarn index. So if it's -1, then it's a matrix element. Otherwise, it gives the index of the yarn that it belongs to in the model. And then the second and third are the X and Y coordinates of to give the location of the element on the cross section. So if you imagine you've got the cross section orthogonal to the yarn tangent, then it gives the distance of the element from the yarn center line. And then the fourth one is the volume fraction, and the last one gives the distance of the element from the surface of the yarn. So supplied with TextGen is an Abacus UMAT subroutine, which will compute the properties of each element. So it's called chamois model final.4. It's in the utilities folder in your TextGen installation. So on my computer, my TextGen installation is in the program files. So it's in program files, TextGen utilities. So you should be able to find it there. You specify the raw fibre and matrix properties, and then it uses the chamois micromechanical model, which is set out in this paper, to calculate the properties for each element individually. And the details of how to use that are on this page. So moving on, so once you've done this section, you create your TextGen model, and then you're ready to export. So one way that we can export is using an Abacus Voxel export. So this generates a mesh of hex elements, and elements are assigned to either the yarn or the matrix, depending on whether where the center point is, within the model. So if the center point is within the yarn, then it's assigned, the element is assigned to the yarn. They use periodic boundary conditions that are specified in this paper by Liam Wongstow. And all Abacus exports include additional .ori and DLD files, which contain information about element orientation, fibre volume fraction, etc. And those are all based on the centre point of the element. So looking at the Abacus Voxel file export, you can specify the number of voxels that you want in the X, Y, and Z direction. Probably for a sort of reasonably thin laminate, you probably wouldn't have, if you had 50 in the X and Y direction, you would probably have fewer in the Z to keep them, the voxels having a good aspect ratio. You can decide whether or not you want to output just the yarns, just the matrix, or both. We'll come back to the Octree refinement in a moment. And then you can choose to have reduced elements, reduced integration elements or not. And then we have various sets of periodic boundary conditions, which you can choose. This is just how you would call this same saving voxel mesh using a Python script. The parameters are given in the API in the documentation on the website. The thing to be aware of with this is that actually this is the function which will always be called, however you generate this, whether it's through the user interface or via a script. This dialog on the user interface is basically populating the parameters in this function call. So you make your selections, and then we're just going to look at the periodic boundary conditions. So the material continuum condition assumes that the you have an infinitely repeating 3D continuum, so it repeats in the directions as shown here, which sort of isn't actually realistic if you were doing, say, a tensile test. It's not strictly true, but that's there if you want to use that one. There is also the single layer RVE option, which basically unties the through thickness constraints and allows free surfaces on the top and the bottom. In actual fact, we've found that the results between the two are very small. The differences between the results are very small. So they're both there. You can try whichever one you like. So having done that, then we create our input file. And I'm just going to, I've got an input file that I've generated for the voxel mesh with just a small set of voxels. This was 10 by 10 by 5, and just so you can see what the output looks like, basically. So we have our nodes, and you can see that this is the node number, and then these are the positions. So you can see for 10 by 10 by 5, I've just cut some out of the middle. So we've got 726 nodes. Outputs the elements. So 10 by 10 by 5, we've got 500 elements again. So this gives the nodes within the elements. And then orientations. So this is telling it that we've got an associated .ori file giving the orientations. And then it specifies the element set. So we've got the element set for the matrix and the 4 yarns in this case. Outputs the materials. So in this case, it would just output the defaults that are included in TextGen. But if you'd set up your materials and if you'd set up various different materials, you can see here it's mat 0 is the matrix, and then we've got mat 1, which is associated with yarns 0 to 3. But if, say, I had 2 different materials for different yarns, then it would associate those. And then it sets up the periodic boundary conditions as specified in the paper. And it's got a set of nodes that are associated with the faces and the edges and the corners. And if you look at the paper, you'll see how those node sets are set up and then used in the equations. So these are the equations specified by the paper. And the thing to note about this is that it does use these node sets, which have got multiple nodes in the equations, and this is why this input file has to be run from the command line. It won't run from CAE because the CAE can't cope with the multiple node to multiple node equations. And then if you go to the bottom of the file, it's got the steps and the field output set up as per the paper. Okay. So that's the input file, and then basically this is an example of a voxel mesh, which is created using the method that we've described, and then you can run that in Abacus command on the Abacus command line as we've described. You can then use the Python scripts which are supplied with TextGen, and they're in the Python libextra TextGen folder in the TextGen installation. The steps to run those are described in the link here. You have to basically edit I think it's the effective matprop file to have the correct file names and whether or not you want to create calculate thermomechanical properties. And once you run that script from within Abacus CAE, having run and got an ODB file, then it will generate a set of properties for you. So a few other things. So on that file dialog, it showed an Octree option. That's a fairly recent thing that's been put into TextGen. So once you check that Octree export box, then it will bring up a second dialog. This actually isn't quite what's in the current installation. It's a bit of a work in progress still. So we have changed it. Hopefully we'll be releasing this fairly soon with this slight change to the dialog and a couple of bug fixes. But basically this does Octree refinement, so you can see that you have finer meshes close to the yarn and matrix borders where there's more detail, and then also implements a Laplacian smoothing algorithm which gives you something closer to a conformal mesh. It isn't quite a conformal mesh, but it might be enough for avoiding things like stress concentrations if you want to do some damage modelling. And it's described in the paper at the bottom there. Another thing that's in there is staggered boundary conditions. If you have a large, say 3D or orthogonal or 3D model, which has lines of symmetries that you can take advantage of, then you can reduce the computational cost of doing your export. The staggered boundary condition assumes that there's an X offset. It assumes that you've got a model which might be something like this. So if you reduce the unit cell, then you can apply boundary conditions which assume that you've got an offset. And in this case, when you choose the staggered boundary condition, the X offset box is enabled, and you can put that in that amount that your unit cell is being offset by. And essentially, it then creates sort of half node sets for these two faces, so that you can match this half and this half up as it staggers and repeats. There's also shared textile. So in the 2D wizard, if you check the shared textile, then you can input an angle, and you can choose whether or not you create also a shared domain. So if you do choose a shared domain, then you can use the shared boundary conditions. So it essentially does pretty much the same as creating the voxel mesh, but they're sort of, well, I can never say it, parallelepiped voxels. So they're basically tetrahedral bricks, if you like, which avoids having a staggered edge along here. It makes this edge straight. The boundary conditions are set up so that when you have this face repeating to over here, then the boundary conditions take into account the fact that you've got both an X and a Y offset between the two faces to get the periodic boundaries. So one last way that you can use the setup with the boundary conditions and whatever is creating a conformal mesh, and you can use this with the file export volume mesh, and this will create a tetrahedral mesh, and we'll look into more detail in a moment at the different options here. But essentially what this does is it takes the textile, it extracts the outline of the yarns and takes that and the outline of the domain and triangulates that to create the top surface. And if you look at the top surface here, you can see that those boundaries from the yarns are sort of included in the triangulation. And then it basically drops prisms down for each triangulated mesh, and then splits that into tetrahedra, spotting where the boundaries of the yarns are. And you can put in a tolerance, a merge tolerance. So if, for example, in the center of where the two yarns coincide, if the distance between the two yarns is smaller than that merge tolerance, then it will remove the small, probably misshapen matrix element in the middle and just create the two yarn mesh elements so that they match. And that can be output to create the boundary conditions and be used in the same way as the previous voxel mesh. So moving on from there, another common thing that people want to do is flow simulation, and there's a tutorial online about using CFX with the volume mesh. So in that case, it's set up so that we can create the volume mesh as we saw on the previous slide. There are various options for creating that volume mesh, so you can choose whether to have linear or quadratic elements. And the project mid-side nodes is if you've got quadratic nodes, quadratic elements, then the mid-side will be used when it's creating the tetrahedra as well. You can choose whether or not to have periodic meshing, and in that case, if you choose for it to be periodic, then it basically creates the surfaces with the yarn outlines and triangulates those, and then creates a corresponding triangulation on the opposite face, and then forces those to match. For the most part, that works. There occasionally it might not manage to do the periodic meshing, but for the most part it works. However, if you're going to do the CFX export, then you would choose none for the boundary conditions, and in that case it will generate a periodic mesh, but just with the output, the nodes, element sets, and the materials. The seed size is what it uses to govern the density of the initially triangulated mesh. So you can govern how large or small your triangulation is using that seed size, and we've already talked about the merge tolerance. So having done that, you can create either a VTK or an IMP file, and I'll just, oh no, that wasn't what I meant to do. Neither was that. So just in case people haven't noticed, when you're doing the export with the volume mesh, I'm just going to leave all those. I'll do what we said, you can see, and then you could choose none. If I do OK now, then when I get to choose my file name, if I click down here, you can see that I can either output as an IMP file or the vtk.vtu file. So there are two ways of exporting that mesh. I'm not going to actually do that now. So when you do the VTK export, it still exports all of the yarn index, orientation, volume fraction information, etc. But they're included in the cell data, point and cell data in the VTU file. It's all included in one file. And you can view the VTU file in ParaView. That's a free download. You can use the viewer. If you want to import a .imp file, there are instructions for doing that if you follow this link on the TextGen website. And I didn't say earlier, but what I will do is I will PDF the slides and send them out to everyone who's attending, so that you'll be able to have the slides, and you'll have access to all of these links. And then after that, you basically follow the steps in this flow simulation guide, and it tells you all about how to set up the boundary conditions, and then how to run the simulation and extract the properties, apply the equations, so that you can then calculate permeabilities. So this is a simulation that's included in this paper down here. This is actually using a Voxel file. Both the Voxel and the conformal mesh will work in the same way, and then from that you can extract the permeabilities. So, another way of exporting a conformal file is the TextGen Mesh export. So this uses the external TextGen library, and when you select the option, it brings you up a dialog that looks like this. So there are different input parameters that you can use, and those are specified on the TextGen page here. Generates tetrahedral elements. Again, you can specify a seed size to say how it governs the density of the mesh. And again, you can save this as either an Abacus or a VTU file. The way that TextGen exports to TextGen and gives the instruction to generate the mesh is it exports the boundaries of the domain and the surface mesh, so that's how, and then applies the constraint that TextGen will conform the mesh to that surface mesh. So that's where getting the surface mesh of this set up correctly will affect how your mesh finally sets up. So that is why there's a set resolution button here. So if you check that, then if you had, say, a very fine mesh on here and you didn't want your TextGen mesh to be so fine, you might check the set resolution, say change it to 20, and that will mean that there's a coarser mesh exported, and that is what will be conformed to when it creates the volume mesh, the TextGen mesh. One thing to say is that you may need to introduce a gap between the yarns in order for the TextGen mesh to be successful. If you have very close yarns or touching yarns, then TextGen may crash. I've tried to catch as many of the exceptions that TextGen generates as I can, but it doesn't always catch all of them. And so really strongly advise you to save your model before you try doing a TextGen export, because it may crash, particularly if you don't have gaps between the yarns. But when you're doing the refine options, then you can specify a gap between the yarns in the wizards. And so one advantage of this could be if it works quite well for 3D models. So where the other tetrahedral volume mesh export doesn't work very well for vertical or near vertical yarns because of the way that the algorithm works, the TextGen will work reasonably well for 3D weaves with vertical yarns, as long as you've made sure that you've got a bit of a gap in between your yarns. Just keeping an eye on the time, so we're just about okay, I think. So the other thing that you might want to do is just export the dry fibres. Meshing of that is easier because you've not got these small areas between yarns. So the way that works is it creates a conformal mesh using hex and wedge elements. So this is based on where you need to have set up your yarn resolution, because it generates a section mesh based on the section points. So these are the section points around the edge, and then it creates a section mesh in this way. And then in order to create the volume mesh, it basically joins up corresponding points in the meshes between the different slave yarns. So again, that's where the resolution of both the number of yarns around the outside and the number of slave nodes makes a difference to your mesh resolution. So you can get a sort of preview of what that looks like using the render textile volume option. I'm not going to do that because of time constraints at the moment, but if you use that option, then you can get a look at what your volume mesh export will look like. And the Abacus dry fibre export uses that. I've realised as I've been doing this that we've got two things that we call volume mesh, which is slightly confusing, but it uses that conformal volume mesh and sets up an explicit analysis. You can specify a deformation in whichever direction you like using the scale. You can set compression plates, and then there's a function which will allow you to adjust small intersections. This function was written for where you have a model which may have some very, very small intersections which don't make a significant difference to the actual model, but might be enough to stop an Abacus simulation from running. And so this basically uses the interference algorithm to find the interference points and then makes very small adjustments to the points. This is slightly exaggerated, but you can see how it's adjusted the sections. And the thing to realise with this is that if the intersection is greater than 1 element deep, then it will put up an error message and say that it can't do the correction, and that is puts an error message in the log window in TextGen. And the other thing that this will do is generate contact surfaces. So you can see you've got upper and lower and whole yarn. So the default is upper and lower. So for a woven textile generated by one of the weave wizards, then it will create upper and lower surfaces for each of the yarns and create contact pairs for the pairs of contact surfaces. The reason the whole yarn one was done was one application which we've used for this is a knitted textile, and for a knitted textile the concept of the upper and lower doesn't make so much sense because it's, you know, they don't necessarily have the upper and lower, so that in that case you can generate a whole yarn contact surface, and then it will make contacts between the two pairs of yarns. And this is a simulation that we did with this knitted textile. So you can see this was the simulation with just one unit cell. It applied deformation in the Y direction, I think that is. And then that was with periodic boundary conditions. And then we changed the simulation slightly, removed the constraint in the X direction. And you can see that this has got a unit cell which is 3 by 3. So in that case, the domain was changed to be that 3 by 3 size, and then you can see that in that case we've got some extra deformations here where that X wasn't constrained. So that just gives you an example of you might need to just change things slightly to set things up for the particular scenario that you want to use. One thing that we did find was that in actual fact for these simulations the Abacus general contact algorithm worked much faster, and so we edited the input file to use that instead. So lastly, just look at geometry export. There are options in TextGen to export step and IGES files. This uses the Open Cascade library, and it's more successful sometimes than others. The faceted option seems to be more robust than when we try to export as smooth, but you can try the smooth if it may well crash, and that's another case of save your model before you try it. If the smooth doesn't work, then often the faceted will, and that basically exports the surface mesh. So if you want to see what your faceted step or IGES export is going to look like, then you can use the rendering X-ray, and that will show you what's going to be generated. So that's again where you might want to change your resolutions to get it looking how you want to look at how you want it to look. The join yarn sections is because by default the or if you don't have that checked, the IGES or step file will have separate sections for each of the yarn repeats with a join in between the parts. If you want to fuse them, you can do by checking this join yarn sections, but it's much slower. It takes a lot longer to export. One thing to note with the geometry export is that you lose all your information about orientations, volume fractions and properties. None of that's exported. It's purely the geometry. In the TextGen scripts folder on GitHub, there is a file which can give you an idea of how, if you exported the geometry and say then meshed in HyperMesh, you can then use those elements generated in HyperMesh. You can extract the center points and then interrogate the TextGen model to get your orientation and volume fraction information. So it is possible, it's just a bit more convoluted. And so lastly, the last export type is just the surface mesh. So if for whatever reason you just want to export that surface mesh, you can do it using the export surface mesh option, and again that's the rendering X-ray and you can export that as a VTU file. You can export it as an STL file. I've done that. I wanted to create some little 3D printed models of some of the orthogonal or the 3D woven files. And so I exported the STL file and we imported that into the 3D printer and it printed out my little models. So if you want to do something like that, that's quite a useful way. The Siren file is just it's a bit of a legacy file, really. We had a go at one point of seeing if we could use any of the Siren meshing options, and so we exported in the Siren file format. So it's still there if you want to use it for any reason. And again, the VTU surface mesh can be displayed in ParaView, and this is actually the view that you can see if you view it in ParaView. So I think that's been a bit of a whistle-stop tour of exports, exporting models and stuff in TextGen. Hope it's not been too fast. I think we've just about fitted into the time. So I will say, are there any questions? I don't know if